You wish to build an aquarium which holds 36 cubic feet of water, and you want the length to be twice the width. What dimensions would require the least amount of glass? All right, so we're dealing with an aquarium here. This is just going to be a rectangular prism. And with this aquarium, although it's a prism, like prisms are usually six-sided, for this, making this out of glass, the top is not going to be glass. Right? The top is generally just kind of like just the cover. It's not going to be a glass cover. But the other 5 sides are all going to be glass: the front, back, left, right, and the bottom. So we're dealing with 5 sides here. What are we trying to minimize or maximize here? Amount of glass, right? So here we're trying to minimize, right, the least amount, so minimize the amount of glass. But in mathematical terms, what are we minimizing? Surface area, right? Square feet, surface area. So we're trying to minimize surface area. All right, so let's look at just kind of writing out an equation for surface area, not a like full formula yet, but our surface area is going to consist of the front side plus the back side. Those are both going to be the same. The left side and the right side, again, those are both going to be the same. And then the bottom. Right, so our surface area is going to be the area of those 5 sides added up. Well, let's look at this. Normally we say this is our length right here, our width, and our height. But it tells us the length has to be twice the width. So L has to be 2 times W. So I'm going to replace this L with 2W. Because our goal is to have everything in terms of one variable. So we still have the H, it's not in terms of W, but we'll fix that in a little bit. And I'm just going to write down the one last thing that we have up here. What's the 36 cubic feet giving us? Volume, right? Cubic measurement, that's talking about volume. All right, well, let's go ahead and take what we've got so far and put together this surface area equation. What's the area of the front going to be? 2W times H, right? Remember, the front and the back are the same, so I'm going to write this as 2 times 2W times H. That's going to take area of both of those into account. Plus, we have a left side and a right side that are going to be the same, so I'm going to do 2 times the area of one of those sides. So the area of the right side here would be W times H. And then how about the area of the bottom? 2W squared. So let's kind of simplify this and combine things a little bit. We have 4WH here plus 2WH, so we get 6WH plus 2W squared. But we still have this problem here. We have H. We need everything in terms of W. Well, what were we given that we haven't used yet? Told us volume, right? That hasn't been used. We can use that to write H in terms of W. Right? Volume is length times width times height. So in this case, it would be 2W squared times height. Well, that has to equal 36 in this problem. So we can solve for H just by dividing by 2W squared. We get 18 over 18 over W squared is our height. So what we're going to do is take that and substitute it in for H over here so that everything is in terms of W. So we have 6W times 18 over W squared plus 2W squared. So this W is going to cancel out with one of the ones there. We end up with 108 times W to the negative first. And I'm writing it with negative exponent just because we're going to end up taking the derivative, and it's easier to think of it when it's written that way rather than 108 over W. So we've got our equation in terms of one variable. Now we want to find the critical value. So we're going to take the derivative of S. We get negative 108 times W to the negative second plus 4W. We want to know when that's equal to 0. So we can factor out a 4 and a W to the negative second. Right, they both have W's. We can factor out the smallest exponent. So if we factor that out of this first one, we're going to end up with negative 27. So the W to the negative 2 cancels out. And if we do 4W divided by 4W to the negative second, the 4's cancel out, so we're just left with 1. But W divided by W to the negative second, we just subtract those exponents. Right? This is like a 1 minus negative 2. That's going to be W cubed. So over here, if we set this equal to 0, it's not going to happen, but if we had 0 for W, that would make the derivative not exist. It would also make the fish not exist because the width would be 0, so that's not going to work. All right, but we can set this equal to 0. We want to figure out when's W cubed minus 27 equal to 0. Well, if we add 27 and take the cube root, our width comes out to be 3. Now, this one doesn't have endpoints like our first problem did, so we can kind of test to make sure this is a minimum and not a maximum using our derivative number line. We know the derivative of our surface area is 0 when W is 3. Let's try a couple values on either side. So if we put negative 1 in to our derivative, so we're looking at this right here. If we put negative 1 in, this is going to be positive, because negative 1's getting squared. And if we put negative 1 in here, that's going to be a negative. So positive times negative is negative. If we put 4 in, this is going to be positive, and this one's going to be positive, so that's going to be positive. So we do have a minimum here. Let's go back and make sure we're answering the question that's asked. It's asking us for the dimension, so it's asking for all 3 dimensions. So we only have the width right now, but we want to give all 3. So our width is going to be 3 feet. Length is just going to be twice that. That's going to be 6 feet. And then our height, we can use that formula that we came up with. 18 divided by 3 squared, so that's going to be 2 feet.